Hello once again and welcome to my channel. In this video today what we're going to be looking at is answering questions on the physical properties of organic compounds, and in this particular case as are related to isomers. This is from a past exam question from the year 2016 of the metric paper. So the question reads, the boiling points of three isomers are given in the table below. So the first one is substance A, 2,2-dimethyl propane. It's got a boiling point of 9 degrees C, and then B is 2-methyl butane, 28 degrees C, and then the other one is pentane, and you find that it's got a boiling point of 36 degrees C. So if you were to have a look at 2,2-dimethyl propane, even before we start answering the question, the chemical formula of 2,2-dimethyl propane, it looks something like this. So you've got dimethyl propane, your long chain is a propane, and then you've got a methyl group on the second carbon and another methyl group on the second carbon, and then you've got your hydrogens, and it would look something like this. Right? So what you realize is that this has got a total of 1, 2, 3, 4, 5 carbons. So just as there are the number of carbons as there are in pentane. Your pentane in this case will just be a straight chain which has got that same number of carbons, same number of hydrogens, hence they are isomers. And then your 2-methyl butane would be having the chain in this format. So, and then on carbon number 2, you've got the methyl group. So you've got one, which is a very short chain. You've got slightly less short, and then your long chain. So that is the one thing that you need to picture in your mind and know what you're dealing with, so that when you do your when you start answering the question, you are able to have a picture or to visualize what you are dealing with. All right, so this here is your long chain, and because it is long, that means that the molecule has got the forces acting over a larger surface area, and because of that it's going to have a very high boiling point. Your 2-methyl butane is slightly longer or slightly shorter than the other one, and therefore its boiling point will be slightly less as well, because it is more compact than the pentane. Whereas with your 2,2-dimethyl propane, it's going to be very small, compact, and at the same time it's not going to occupy a large surface area. Hence it will have a lower boiling point, because the intermolecular forces that are acting on a small surface area. So now let us now start answering the question. Define the term structural isomer. Well, a structural isomer, the definition of that, these are compounds with the same molecular formula. So you'd need to include that they've got the same molecular formula. But different structural formulae. Same molecular formula, different structural formulae. And hence the properties will be different. Right? So that is the general definition that you'll get even from the exam guidelines. And then 3.3, it says explain the trend in the boiling points from compound A to compound C. So what is the trend? The first thing that you're going to observe is that from A to C, the first thing that the observation is that there's an increase. From A to C, there's an increase in the boiling points of the substances. That's the observation, right? So now the explanation for that observation then becomes as follows. 3.3, I'm just going to write it here. 3.3. So BP increases. So that's what you're observing from A to C. And the explanation, as we are saying, is one, the structure becomes from A to C, structures become less branch. If the structures are less branched or less compact or less spherical, it means that they're going to have a larger surface, or they become longer chains. They will have larger surface areas. They will have larger surface areas for the intermolecular, over which the IMF act. IMF act, over which the intermolecular forces act. So that's the first thing. And therefore, what is the implication of that? The intermolecular forces become stronger as you move from A to F. So the IMF becomes stronger, or there will be stronger van der Waals or stronger London dispersion forces. They become stronger. So you can actually state the type of forces that you have. And if these intermolecular forces have become stronger, it means therefore that more energy is needed to overcome the intermolecular forces, right? And that is the reason why you observe what you observed. Or you could actually explain it from C to A and give the opposite reasons as to these. So if you're explaining from C to A, what happens? The boiling point decreases from C to A. Why? Because the structures become more branched, and therefore they will have smaller surface areas over which the IMF acts. The intermolecular forces will therefore become weaker, and therefore less energy is needed to overcome the intermolecular forces. So very simple, very straightforward, and it can be explained, right? And then your 3.4, which one of the three compounds, A, B, or C, has the highest vapor pressure? Refer to the data in the table to give a reason for the answer. Well, the one with the lowest boiling point must have the highest vapor pressure. So 3.4, the one with the lowest boiling point will have the highest vapor pressure. So compound A has highest vapor pressure. Reason, it has the lowest boiling point. Remember, substances boil when the vapor pressure is equal to the external pressure. And then the next question says, use molecular formulae and write down a balanced equation for the complete combustion of compound B. So compound B is 2-methylbutane. So the chemical formula of that is C5H12 plus O2. Remember, in the combustion, it's the burning in oxygen, and therefore the compound, the products are carbon dioxide plus H2O. And when you look at this, how many carbons do you have? You've got 5 carbons. So, and how many hydrogens you have? You've got 12 hydrogens. So it becomes 6. And so when you look at this, you've got 5 carbons, and then a total of 6 plus 10, which is 16. Here you've got 2, so you multiply that by 8, and therefore this is the product or the balanced equation for the reaction. You need to know the chemical formulae of the reacting substances. You should be able to know the products of the reaction, which is in this case carbon dioxide and water, and nothing else. And thereafter, you just need to balance the equation. Thank you very much for watching. I hope this makes sense and that this type of question would be one that you would enjoy answering. If you like the video, please like, share, and also send us your comments as feedback for the video series. Thank you very much. Bye-bye.